The Center for Solar-Terrestrial Research is a collection of individuals, faculty, research professors, graduate students, engineers, that are really gathered together to try to learn fundamental physics of the solar terrestrial system. That is, we study processes going from the surface of the sun to the surface of the earth, and we look at fundamentally what causes those physical processes. CSTR is within the physics department at NJIT, and our primary mission is research into geospace physics. That is, we look at the physical processes which generate solar flares or coronal mass ejections, how that energy is transferred, how it's dissipated, and how it impacts the Earth's upper atmosphere and magnetosphere.
Space weather is part of the environment of the Earth. And in order to understand the total environment of the Earth, from the oceans to the atmosphere to space, space weather in solar terrestrial research plays a very important role in understanding the total environment of our Earth.
CSTR has a number of different instruments, of assets that we use to study the upper atmosphere and the magnetosphere. We have a collection of instruments in the Antarctic located at the 3 manned U.S. stations, namely McMurdo, South Pole, and Palmer Station. We have instruments distributed at Automated Geophysical Observatories across the Antarctic continent, which are unmanned and operate robotically, remotely.
The CSTR operates the Big Bear Solar Observatory, which is the largest optical solar observatory in the world. 1.6 meter telescope. It's able to produce the highest resolution images of the sun. In addition, we have the Owens Valley Solar Array, which is a radio telescope, multi-frequency imaging telescope that's observing above the surface of the sun.
All of these instruments measure different things about this upper atmosphere and magnetosphere system and really give us insights as to how that system operates, and thus an idea of what the potential impacts on different systems can be. Being located within an institute of technology, we also look at the direct applications of that physics. That is, what are the technological impacts? How are spacecraft charged? How are GPS signals disrupted? Power line influences, HF radio communication, these types of very real practical applications. We are largely an experimental group where we build and field new types of instruments to get unique measurements, and we really are leveraging that Institute of Technology approach in order to contribute both to society as well as to the educational mission of our university.
So the center helps with our research by providing a broader range of subjects for us to collaborate with. We're able to work with each other. We have students who are able to learn a broader range of science than they normally would.
I think the CSTR is really unique because it's one of the few research centers which really joins together observations from the sun all the way down to Earth. We have people here that study the sun, study what it produces. We look at the interactions between that and the Earth's magnetic field, and then we see how that affects what we see on the ground. So we can really see the entire system here at the CSTR.
My experience as a graduate student at the CSTR has been very good. I've had the opportunity to work with some very interesting people on some very diverse research projects. The CSTR is preparing and helping me with my research by providing me opportunities to attend conferences, by the feedback that I get from fellow graduate students and professors, and also the diverse research projects going on at the CSTR.
Citizen science is a way to conduct science that involves people who aren't doing this for a profession. So we will get observations and participation from people all over the globe voluntarily, and they will work with us to help discover new things. But in citizen science, it's really two-way. We go out there, we do some outreach, but at the same time, we get just as much back from the people participating as we give out to them.
So I think the center has a very, very good future in terms of its overall impact and understanding of the total solar terrestrial process from the sun to the surface of the Earth.
The impacts of space weather are real. We see them daily in terms of GPS. We see them in terms of spacecraft charging and spacecraft operation. Thus, it's a really exciting time for the space weather community, for solar terrestrial research in general, because we're really just starting on this new era of research and discovery and mitigation.